So, what is a UV space? As you can see, I'm in 3ds Max, so I can demonstrate the UVW space or the UV space in a better way. So, now I have here my 3D object. Now, you know that your 3D object lives in X, Y, and Z space. So, what is exactly UVW space? Now, we call the 3D space that our 3D object lives in an X, Y, Z space. And UVW space is our texture space. So your textures will be living in a UV space, not UVW. But to get the UV, so we'll start with the UVW. So now each vertex or point on your object has a position in XYZ and corresponding position to that in UVW. So for now I have the exact same position in XYZ and UVW. So this is my 3D space and this is my texture space. So my texture, for example, is going to be an image. So it's going to be a 2D image. So how a 2D image can live in 3D space? Well, this is not going to be the case. In this space, what we do is we delete the W space. So I'm going to delete the W space. So we now only have UV space for the texture. So when we have UV space, so this object cannot exist in 3D space. So what we do is this object will be now, for example, if I'll just zoom in just a bit. Now you can see I have this vertex right here and this one on the other end. Now they both have the same X and Y space, X and Y coordinates, but they have a different Z, which was here, different W space. But because we don't have a W axis, this what would happen. So here's our 3D object in UV space. So you can see those faces on the sides, they just disappeared. So the only faces that we can map or we can apply texture to is this face on the front and the other face on the back. Okay, so what is the solution for that? Well, the solution for that is we unfold our 3D object to fit in 2D space. So each vertex will have a unique position. So changing the vertex position in UV space does not alter your 3D object, but it will change how your 2D image will be applied to 3D object. So I think now you understand this, so let's see the different mapping that we can apply. So go ahead and so when we have a 2D object like this 2D plane, and when we project the texture on it, which is this let me show you the texture that we're using. Okay, it's just a checker map, so we'll go there. So it's just this regular checker map. Okay, so when I project it on a 2D object, so it's very simple, you can see it's just easy to do. Then let's see now when I have a box. So this is my example when I told you that only these two faces will be mapped. Okay, so when I try to map this from the top, I can only map this face and this face, because these faces does not have any coordinates in the UV coordinate. So you can see only the pixels on the edge are being repeated along these faces. But now let's see the other one, which is the box mapping. So I will be repeating the texture on all of these faces. So each face will have a different coordinates in the UV space. Therefore you can apply this texture to these faces. Okay, so moving on. Now when you have a different shape, for example, we have here a sphere. So I'm trying to apply a UV, a planar projection. So I'm trying to apply my texture from the top. So if I look from the top, you can see it's very normal. It's working good. Okay. Look from the bottom, it's the same thing. But when I look at the sides, you can see this is not working. So my texture is getting stretched along the surface. So I can do box mapping for that to try to fix it. And if you look at it, you can see it's when you look at it directly from one side, it's good from the center only. So it's getting distorted just on these edges. So you can see that it's not a good projection. So when we have a sphere, what we do, we apply spherical projection. So you can see this, how it's actually working better. So we project from a sphere. So if you look, you can see here's your sphere. Your texture will be projected from this sphere. Okay, now let's say we have a little bit more complicated thing, not just a checker map. So your checker map will look natural with even with this box mapping. But let's say we have this box, and I have now an image. So let me show you the image that I'm using. Okay, just this simple one, just simple ground texture, and what I have is just this green line. So I'll be using this to demonstrate something else. I'll be showing you that in a minute. So this is with the planar mapping. I'm applying the mapping from the top. You can see it's very normal from the top. It's working good from the bottom, and you can see the sides. Okay, so let's see the box mapping now. Now the box mapping will repeat my texture on each face. So you can see the texture is getting repeated on each face in each one of these faces. Now in this case, it is not what I want. Okay, I don't want my texture to be repeated on each face because it's not natural. So you can see the repetition. So what I want is I want my texture to wrap around the whole surface, so the whole object. So I unfold this object. You can see now my green bar, my green line is continuing from one face to the other, and my texture is being cropped onto the whole surface. So what we do is we unfold the surface into UV space, we apply the texture using planar mapping, then we take it back to XYZ space so you can see your object with the texture that you're applying to. So let's see now this object. Now here's the object in UV space, in XYZ space, sorry, it's a 3D object, and here's my object, my box unfolded in UV space. You can see here's this face is actually this one. So we select all the faces, and here is my box is being flattened like in a plane, in 2D plane, so we can apply texture without any distortion. So let me see my texture applied. I'm just gonna wait a bit. So you can see this green line. It's continuing from this face to the other face to the other one. So if I'll just select something like this one, and see. So here's the face that I'm selecting. You can see the version of the texture that's being applied to this face, and this will give me the continuity of my texture around my object. Okay, so I hope that gives you a sense of UV space and what are UV coordinates.